Hi students, in this video I will show how to solve the minimal cover problem. Yes, it's very important problem, so note down properly. So here the question it will be, construct the minimal cover for the given set of functional dependency. A tends to B, C tends to B, D tends to ABC, AC tends to D. Okay, so here A is called as the determinant, B is called the dependent. Okay, so by using A we can determine the B. So A is called the determinant and B is called the dependent, as well as C is called the determinant and B is called the dependent, like that. So in case of the minimal cover, so the first step is that we need to remove the right hand side extra attribute. So here step 1 is always right hand side should be a single. So here right hand side it should be single. So if we consider this, A tends to B, so here this right hand side is single, so no need to worry. So in the same way C tends to B, yes, the right hand side is single. Next here D tends to A, B, C, so that's why D tends to A, D determines B, D determines C, so the right hand side is single. Next AC determines D, so here, so that together A and C it's going to determine the D, so that no need to decomposition here, so that no need to decompose AC. Okay, so that write as it is. So this is your step 1, very simple. Next step 2 is remove redundant key. Remove redundant key. So here the first thing is that here A tends to B, C tends to B, D tends to A, D tends to B, D tends to C, as well as AC determines D. So this is your final attribute, so that for these keys we need to remove the redundant key. So here if you want to remove this, if you want to remove A tends to B, so the first thing is that we need to find the A closure here. So A closure here. So according to the reflexive property A, it always determines the A, so that A, it determines A only according to reflexive property. So if you want to remove this set, that is A determines B, so according to that reflexive property A closure determines A itself. Okay, so by using this A, if you observe this sets carefully, okay, so from the other sets we can't determine B. So consider A tends to B, no, it's not there. D tends to A, D tends to B, D tends to C, AC tends to D. So that if we remove this A tends to B, we won't get this B from the other set, so it's not a redundant. Okay, so A tends to B, it remains as it is. So consider the next set, that is C tends to B, so that once again we need to find the closure properties of the C. So according to the closure property, so that C tends to, C determines C only according to the reflexive property. So if you observe the other set here, okay, so if you want to remove this C tends to B, A tends to B, no, it's not possible. D tends to A, D tends to B, D tends to C, AC tends to D, so that we have to use this set as it is. Okay, it remains as it is. Next consider the D tends to A, D, A. Okay, so if you find out this closure property of D is, so yes, from the D we can find the D only according to that reflexive property. So here, yes, if you observe carefully, from D we can get how many attributes, so that if you observe carefully, okay, yes, here Okay, so now we have to remove, we want to remove this D tends to A here. Okay, so from D we can get the B. Yes, it's possible. Okay, so next from D we can get C also, isn't it? So C. Fine. Next, so we are getting from D, we are getting B as well as the C, but we are not getting the A. So isn't it? So that's why place it as it is. Okay, D tends to A, we have to use as it is. Okay, so next is, if you want to remove this D tends to B, then according to the closure property, so D, it will determine D itself. Yes. So next, from D we can get A also here, so that if you want to remove D tends to be here, so that from D we can get A. Yes, as well as we can get C also. Yes, so D tends to A tends to B, so that from D it determines A, from A we can determine B, transitive rule. Okay, so yes, we can get all these attributes from D itself. So no need of this set, so that this D determines B is a redundant set. Okay, so we can remove this D determines B easily. That's it. Okay, so next is D determines C. D determines C according to the reflexive property. Yes, D, it will determine D only. So in spite of this set, so D, it will determine the A, and then so D determines B as well as yes. So if you observe carefully, we can't get this D, C with the help of other set, so that's why we have to keep this set as it is. So it's not a redundant set. So if you consider the last set, that is AC determines D, so that if you consider the closure property of AC, then write AC as it is. Okay, so here yes, so from this AC we can't remove this AC determines D, because from the other set we won't get this value, isn't it? Right, so that's why we have to keep this AC determines D as it is. Okay, so this completes your step 2. So the step 3 is that so that left hand side, it should also contains the single attribute. Okay, so that in the left hand side also it should contains only one attribute. Okay, contains only one attribute. So here A tends to be, yes, it's there. C tends to B, D tends to B. Next here, if you observe carefully, this here D determines B, it's a redundant set, so that's why, so don't include for the third step. Okay, next D determines C, next AC determines D. That's it. Okay, so next is that, so in the left hand side, yes, A determines B. Yes, in the left hand side it's a single attribute, so that no need to worry. C determines B. Here also the left hand side it contains only a single attribute, so no need to worry. D determines A. Yes, single attribute, no need to worry. D determines C. Here also single attribute, no need to worry. But here the problem is here, so AC determines D. So here if you observe carefully, if I remove this A, okay, if I remove this A, then closure of C, then closure of C is C only according to the reflexive property. By using C it determines C only. Okay, so by using this C we won't get the A here. So observe carefully, A determines B, C determines B. Okay, so D determines A, D determines C, AC determines D. So by using C, we won't get A. So by using C, we won't get A. So that's why we can't remove A. So we can't remove A. So next, consider AC determines D, right? So next thing is that if we remove C, okay, so by using A, okay, by using A, we won't get C. So that, yes, observe carefully. A determines B, C determines A, D determines A, D determines C, AC determines D. So that if we remove C, then by using A, we can't determine C. So that's why it's not possible to delete C also. So the final set is A determines B, C determines B, D determines A, D determines C, as well as finally AC determines D. So this is your full and final list or the minimal cover for this problem.